Hello, Laoshi. How are you?
Hi guys, I'm good, thank you.
Laoshi, we have a question.
Yes, come here guys and take a seat.
Thank you, Laoshi.
Chinese tea?
Yes?
Here you are. Okay guys, I'm listening.
Laoshi, from the previous course, we have learned that projected line has three relative positions with respect to the projection plane. The projections of both vertical lines and parallel lines can reflect their true length on relative projection plane, but the projections of general position line cannot do. So our question is how to capture the true length of general position line on projection plane.
Good question guys, but I'd like to ask you a question before answering yours. So could you tell me why the projections of both vertical lines and parallel lines can show their trueness?
Because of the authenticity from features of orthogonal position.
Good job. According to the feature of authenticity, when lines are in parallel with the projection plane, the projections on relative projection plane show their trueness. For example, take this pencil as a line and take this piece of folded paper as two-view projection system. So could you hold it for me, Sava?
Of course, Laoshi.
Thank you. And turn on the torch in the front of this two-view projection system. Please hold this for me. Thank you. Okay, take a look at here, guys. If we place the line as parallel line, which is in parallel to V-plane,
Yes, Laoshi.
and place the torch far away so that the light ray is parallel to each other, hypothetically, right? And there will be a shadow on V-plane. And as we can see from the shadow, the length of the shadow equals the length of the pencil, theoretically.
Yes.
In other words, the projection of this parallel line show its true length.
Yes, Laoshi.
So far, so good?
Yes.
However, if we place this line into general position, which is not parallel with any projection plane, take a look at the shadow again. The length of the shadow, in this case, doesn't equal the length of the pencil.
Yes.
Yes, so it means the projection of this general position line cannot show its true length.
Yes, Laoshi.
So back to your question, how to capture the true length of the general position line on projection plane? I'm going to tell you on screen.
Okay, Laoshi.
Okay, what we are going to do is using right triangle method, which is also called TM in short. As you can see from the screen, there is a general position line in two-view projection system and its projections. The principle of RTM is to create a right triangle in the projection system, taking the general position line as hypotenuse, measure the length of two legs of the right triangle, then copy them to the relative projection plane and create a thin right triangle. The hypotenuse of the copy of the right triangle on projection plane show its true length of the general position line. Did I make clear?
Yes, Laoshi.
Good. The principle is simple, isn't it?
Yes.
Now I'm going to tell you more specifically based on an example. Now take a look at here again, guys. There is a general position line, AB, in two-view projection system and its projections. Lowercase ab on H-plane and AB apostrophe on V-plane. Now we're going to capture the true length of line AB on projection plane based on RTM. First of all, according to the principle of RTM, we need to create a right triangle in two-view projection system, right triangle ABC, which must satisfy three requirements. First, taking line AB as hypotenuse. Second, The right triangle must be orthogonal to one of the projection planes. We make it to H-plane in this case. Third, its two legs must be parallel and orthogonal to the same projection plane, respectively. So, AC is parallel to H-plane, BC is orthogonal to H-plane. After the right triangle being created correctly, we can easily measure its two legs. Lowercase ab, which is the projection of line AB on H-plane, equals AC, one leg of the right triangle. Another leg, BC, shows the height difference, also called delta Z, between point A and point B, which can be measured based on AB apostrophe, the projection of line AB on V-plane. Let me show you how to do that. Drawing a horizontal line from point A apostrophe to the line BB apostrophe, there will be an intersection point which can be named point C apostrophe between two lines. Point C apostrophe also is a projection of point C on V-plane. After that, we can see that the length of BC apostrophe equals the length of BC, which is delta Z. After we measure the length of two legs of the right triangle ABC, we can copy them and make a same right triangle in projection plane. Lowercase ab equals AC, so it's one of the legs of the copy on H-plane. Then we could join another leg of copy starting from either point lowercase b or point lowercase a with the length of delta Z, which is the length of BC apostrophe, ending with any lowercase letter as we want. Finally, the copy of the right triangle is completed after we copied its two legs, lowercase ab, lowercase bd on H-plane. Lowercase ad is the hypotenuse of the copy of the right triangle, which shows the true length of the line AB on H-plane. Did you get it, guys?
Yes, Lordship.
Very clear.
Great. Now I'm going to give you assignment as a homework. You have already learned how to capture the true length of general position line AB on H-plane by RTM.
Yes.
So could you tell me how to capture the true length of this general position line AB on V-plane next time?
No problem.
I think I can do that.
Awesome. Now, cheers!
차 하이밀리앙.
Oh, your Mandarin going well. Good for you. 干杯!
깜빼.